Now, today we will start with chapter 11, lesson 3, which is talking about surface areas of pyramids and cones. We will learn how can we find the surface area of the pyramid and the cone. Now let's start with the pyramid. What is the pyramid? Now, both of the pyramid and the cone, they have something that is something in common, that they have only one base. We say that the prism and the cylinder, they have two bases. Here, it only have one base. Now, the pyramid, let's start now with the pyramid. The pyramid is a polyhedron that one of its faces is a base, as you see in this picture here. This is a pyramid. They have a base from the down, and they have other faces. Other faces, they call them lateral faces. These lateral faces, as you see from here, it comes from one side from the base, make a triangle, okay, until all of these triangles meet at a point, or at a common point. We call it a vertex. So we have a base, only one base. At each side of this base, there's a triangle. All of these triangles making a lateral faces. Now, all of these lateral faces, all of these triangles meet at one point. We called it vertex. Now, for the pyramid, as we did in the prism, we said that we count how many sides in the base of the prism. If it is 4, we can say rectangular prism. If it is 5, we say pentagonal prism, hexagonal prism, triangular prism. And here we have the same. According to the base, we will name the pyramid. We can say triangular pyramid, hexagonal pyramid, square pyramid, and so on. So you name a pyramid by the shape of its base. Now, now we will talk about two things, the slant height and the altitude. Now, the altitude is a line segment. It is perpendicular, or it comes from the vertex, perpendicular on the plane of the base. This pink line, we called it a altitude. The length of the altitude is a height. So the altitude is a line segment coming from the vertex, perpendicular on the base or on the plane of the base. That's one, we called it a height. Now, there's something also we call it slant height. What is the slant height? The slant height, look at this triangle here, or look at any lateral face. Now, the altitude that's from the vertex perpendicular on the side of one side from the base, or that is as a length of the altitude that is perpendicular on the lateral face, we call it slant height. So we have here two things. The height that is perpendicular on the base. This is the height. The slant height, it is as the altitude on the, it is also perpendicular, but here on one side. I mean, like the height, it is inside a shape. The slant height, it is an altitude that is on the lateral face of the shape, that is outside the shape. Is it clear what's the difference between them?
Yeah. Yes. Yeah.
Okay. So the length of the altitude is the height of the pyramid. This altitude that is perpendicular on the base, the plane of the base, is the height. And the slant height is the length of the altitude of the lateral face of the pyramid. Here is the slant height. Now, sometimes, do you remember when you talk about if you have also you need some, we'll talk about them here, and don't forget the altitude here. We'll talk about them later on. But this is first here. We talk about what is the pyramid. It's a shape that only has one base with many lateral faces, many lateral triangles that are connected with a common points. We called it a pyramid. We will name the pyramid according to the number of sides on the base: hexagonal, square, pentagonal, and so on. And also here we have to differentiate between two things: the height and the slant height. To find the surface area, you will use only the slant height. The height that I need is the slant height. Now, while we are talking about the height, I will use it to find the volume. So this one, I needed to find the volume, and the slant height, I needed to find the surface area. And we must differentiate between them. Now, look at this picture here. This is the red arrow is the height. That is an altitude that is perpendicular on the plane of the base. And the slant height is the blue one. That is an altitude of the lateral face that is perpendicular in one side of the lateral face, or on the lateral face. This is the difference between them. Now, let's now talk about how can we find the lateral area and the surface area of the pyramid. Now, look at this picture here. This is a pyramid. They told me that if you want to find the lateral area, I'm talking about the areas of the all triangles here. This triangle, and this triangle, all the triangles, the lateral faces outside here. The lateral area of the lateral faces here is half the perimeter times the slant height. So I will multiply here the perimeter. Now here, so what I have to do? I have to find the perimeter of the base. The first step, I need to find the perimeter of the base. Then I multiply it by the slant height. We are talking about them before. So to find the lateral area, I need to find the perimeter of the base. This is the first step. I will multiply it by the lateral area by half. So to find the slant height, it is the product of the perimeter of the base and the slant height. Now, how can we find the surface area? As we remembered before, we talked in the prism, we said that for the prism or for the cylinder, we said that they have a lateral area plus 2 times the area of the base. Why I multiply it by 2? Because I have two bases for the prism and for the cylinder. Here, I don't multiply by 2 if I want to find the area of the pyramid or the cone. I just add it to the area of the base. So for the prism and for the cylinder, the surface area is a summation of the lateral area plus 2 times the area of the base. Here, times plus 1 times the area of the base. Then there also, we said that if you want to find the lateral area, how can we find the lateral area for the prism or for the cylinder?
Perimeter
The
times
perimeter. Yeah.
Times what?
Multiply.
By h. And here, okay, so I need to find the perimeter times the height. In the prism or in the cylinder, I look at the height that is here. Now, both in the cylinder or in the prism, the slant height is the same as the height. Why? Because if you look at, where's the whiteboard here? If you look at this cylinder here, we say that we have we have two definitions. The height that is perpendicular on the base, and there's another altitude that is perpendicular on the lateral face. So in cylinder or in the prism, if you say height, or if you use the height or the slant height, they have the same length. So you will use the height. Now, to find the lateral area here, you will say, to find the lateral area here, we said it is the perimeter times the height. This is for the cylinder or for the prism. For the pyramid here, we said that the lateral area, yes, here, since we have only two bases, I say half, we have perimeter. Here, since we have one base, we say half of the perimeter times, I need the height, but here I don't use the height. This one, I will use the height of the lateral faces. Why? Because I'm talking about the lateral face. So I will use the height of the lateral face. Here, where is the height of the lateral face? Which is the slant height. I will name it now with L. So this is the difference between them. In the prism, so in the prism or in the cylinder, we said that we have to find the surface area. We add the lateral face, which is half perimeter times the slant height. The slant height is the altitude of the lateral face, because I'm talking about the lateral area, times half of the perimeter. Now, since I have only one base, so I multiply it by, I add it to the base of the, or the area of the base, sorry. For the prism or for the cylinder, we said P, the perimeter, times the height of the shape, plus 2 times the area of the base, since we have two bases. Now let's have an example here. Finding, in this problem here, we will learn how can we find the surface area of the pyramid. Now, as we said, if you want to find the surface area, it is half the perimeter times the slant height, the perimeter of the base, plus the area of the base. This is the slant, this is now the surface area of this shape here. Let's put it here to remember what we must do. Now, so I need now to find the parameter of the shape, the length of the shape, the slant height of the shape, and the area of the base. Look at this shape here. What is the shape of the base?
It's a hexagon.
Hexagon, yeah, it is a hexagon. So since we have now a hexagonal pyramid, so I need now to find the perimeter of the hexagon and the area of the hexagon. So we need to find now the perimeter of the hexagon and the area of the hexagon.
The parameter is 36.
Teacher, is it triangle? Because
Sorry?
it's not given shape. It's not given if it's regular or not.
Ah, I forgot to tell you. Here they told you that at the here only the shapes are where it's written. And it's a regular pyramid here. In the book they told you that assume that all the shapes are regular. But if they didn't tell you it's not irregular, you will deal it with another thing. So all the shapes here are regular, or all the pyramid here are regular. So here we have now a hexagon, and as they told me that it is a regular polygon, a regular pyramid. So that means all the triangles, all the bases of the hexagon here are regular. Now we need to find the perimeter here. As you remembered, how can we find the perimeter of the hexagon?
By multiplying the perimeter by the sides.
Number of sides.
Yeah, so it is n times s. This is for the perimeter of the hexagon. How many sides for the hexagon here?
6.
6.
Now,
6.
look at the length of the side for the hexagon.
It's 6.
It's also 6. So I now find the perimeter of the hexagon, which is 36 inch. I did it. Now, where's the slant height? Is it written?
Yes, it's 9.
It is 9. This is the slant height. So it's written. Now I need now to find the area of the base. Now, since we said that the base is hexagon, we said, as we remembered before, what is the area?
Half times apothem times perimeter.
Half the perimeter times the apothem. Now, where's the perimeter? We found it. It's 36 times half. Now we need the apothem. Now, don't forget, here we have 3 things that are perpendicular. There's the height. The height is from the vertex up to the plane of the face. This one is a height. That's the one, or the altitude. But now it is perpendicular on the lateral face is the slant height. So we have the height, we have the slant height, but there's another line segment that is perpendicular, that comes from the center of the shape, perpendicular on the base of the base, That's we call them here an apothem. That's we talked about them before. So where's the apothem here? Or what is the negative of the apothem?
3 square root of 3.
Yeah,
It's given.
square.
Here I will clear my drawing here. They told me that it's 3 square root of 3. Now let's simplify them here. 18 times 3, 54. So it's 54 square root of 3 inches squared. So by now we find the area of the base and the perimeter of the base. So the perimeter here is 36 and the area here is 54 square root of 3. Is it clear?
Yes.
Okay.
Yeah.
Now after that, we said at the beginning here that the slant height, the surface area, is the is half the perimeter times the slant height plus the area of the base. Let's substitute now. What is the perimeter? We found it. It is 36 times. We said that the slant height here is 9.
Yeah.
Plus, what is the area of the base?
54 square root of 3.
54 square root of 3, yes. So it is 72 plus 54 square root of 3. We can also simplify them by multiplying square root of 3.
Teacher,
Yes.
how did you cancel 2 and 9?
I imagined it's 4. Okay, because sometimes I wrote 4 like this. And I see it like this. Okay, thank you. So this is 9. So 18 times 9 is 162 plus 5 square root of 3. The total area here is 170.6 inches squared. This is now the literal area, the surface area of the pyramid. Is it clear?
Teacher, is it supposed to be 54 square root of 3?
Sorry?
54 square root of 3, right? It's supposed to be a little bit bigger than 170. Like when I imagine it.
يا الله ايش فيهم. Okay, I write it in the I'm sorry. It has to be 2. يا الله. I write it 5 in the calculator. I'm sorry, yes. And by logic, how it comes 170? Okay, thank you. I'm sorry. Inshallah, this is the last answer. It will be 264.1 inches squared. Do you have any question?
No, thank you.
Okay. Now, another example here. A A square pyramid has a base edge of 5 meters. So here, from its name, we have a square. The base here is a square. We have a sides. This side here. There's another side here. Another side here. And another side here. Let's make a pyramid. The edge of the bases is 5, or 5, sorry. That means they are the same. Here is 5, here is 5, here is 5, and here is 5. And the slant, they have a slant height of 3. Here now, the slant height is 3. What is the surface area here? Now, as we say, the surface area is half the perimeter times the slant height plus the area of the base. Now, how can we find the perimeter of the square? It is a regular polygon. So it's and times s. Since we have now 4 bases or 4 edges for the base, we say 4 times the length of any side is 5. So we say now it's 20 here. Times, where's the slant height?
3.
It's written, it's a 3. Plus. Now let's go talk about the area of the base. Where's the base? It's also a square. And as you remember, the area of the square is any side squared. This is how can we find the area of the square. Which is 25. Now 30. Plus 25 is 50. meter squared. Is it clear?
Yes.
Yes.
Yes, teacher.
Yeah.
Okay. Now, sometimes the slant height is not given. You must calculate it before you can find the lateral area or the surface area because we need it. Now, finding the lateral area of the pyramid. This is a problem number 2. A pyramid of Cestius is located in Rome, Italy. Using the dimensions in the figure below, what is the lateral area of the pyramid here? So, this is now the shape of the pyramid. They told me that I only give you the height, which is 36.4. And I only give you the length of the edge, which is 30. And I ask you to find the lateral, the lateral area, yes. So here now, they ask me to find the lateral area. As you said, the lateral area is half perimeter of the base times the slant height. Now look at the base here. What is the base? What is the shape of the base?
Square.
It's a square.
Square.
And we need to find its perimeter, which is 30 meters times by 4.
120.
Times half. So I found now the perimeter. Now I need to find the slant height. But the slant height here is not given. They only give me the height of the pyramid. So look at here. Here now we have this height, but I don't need it. I need the lateral height, or we call it the slant height. Now, if you look at the lateral height and the height, they are, the slant height is the hypotenuse and of right triangle, and the height is one leg of the right triangle. So here, let's draw them here. Like, this is the height, which is 36.4. This is the slant height. Now, look at this side here. To find the slant height, I will use the Pythagorean. How can I find the length of this leg here?
Half the side, because the height bisects the side. It's in the middle.
So it's 15 meters.
So it will be, so here, since now this is as a 30, this is now a 30, this will be now a 30. And since now the height is it is perpendicular on the middle of the plane of the face, so it's cut them into two equal halves. So if this is 30, it makes this one 15 and this one 15. So now, back to my triangle. Here I have 15. Here, this is the slant height. I need to find them. And here now, this is the height that's also given. Can I find now the slant height?
Yes.
Yeah, we can.
By
Pythagorean.
Theorem.
Pythagorean, yeah. So the slant height, let's name it with x. X is the square root of 15 squared plus 36.4 squared. Square root of 15 squared plus 36.4 squared. What happened here? So the slant height now is 39.3 meter. This is for now the slant height. So I found now the slant height, which is 39.3. Now here it is this is 30, so it is 60 times 39.4. So the total surface area of this pyramid in Italy was 2,362 meter squared. Is it clear?
Teacher,
Yes.
if you can explain the L again.